And with that, I think we're ready to bring Jim on. I just talking before, and Jim started at the field station in 1980. If you look at the extensive publication record on the field station website, I saw the earliest publication there with Jim's name on it was in 1984. And following that, I can't say there are countless entries from Jim because they could be counted. But I'm going to say they are uncounted because I didn't take the time to go through scrolling several pages through probably a few hundred articles, many of which are authored or co-authored by Jim Reinartz. So it's really an impressive record. And tonight we're going to hear from Jim, the senior scientist at the UWM field station, longtime friend of the Cedarburg Bog, and has for us a sampling and I think a significant synthesis of what he has learned throughout his, I think we have to call it a long career at this point, and much more to come. So thank you for joining us tonight. Thank you, Jim. We look forward to hearing all that you have to say. I'll stop sharing my screen now if you want to go ahead and share yours. And we will take time at the end for some questions. So if you happen to think of a question, you want to put it in the chat in the meantime, that'll be totally fine. And we'll get to those at the end.
Okay, am I shared there?
You are. It looks good. Thanks, Jim.
Shared. Boy, thanks everybody for being interested in the Cedarburg Bog and giving me a reason to talk about it. I love to talk about what I know about the Cedarburg Bog and learn more about the bog. It's really an amazing place. It's a true wilderness area that's only half an hour, 45 minutes, less than 45 minutes from the UWM campus from downtown Milwaukee. And it is huge. It's 3.5 miles from north to south, Highway 33 at the north end, Cedar Sauk Road at the south, mile and a half to two across. This is a mile from here to here. So it's a big wetland. The whole wetland, which is all of this essentially forested looking area through here, is about 2,300 acres. Of that 2,300 acres, about 1,900 acres of it is state owned, either by the Department of Natural Resources or this hatched area over here is the part of the Cedarburg Bog that's owned by the UWM field station. The rest of the field station is in the upland over here. It's not really a recreation area because it's a wilderness area. There are essentially there's only one trail in the interior of the bog, which is this university's boardwalk in the center of the bog. And then at the north end off of Highway 33, there's some very nice trails. There's a trail into Watts Lake and trails into this little 10-acre clearing, and then you can find your way into this area over here. It's pretty popular with deer hunters, bow hunters. And then at the south end off Cedar Sauk Road, the Friends built a nice boardwalk into Mud Lake. And if you get your canoe or your kayak into Mud Lake, you feel like you could be in central Canada. It's just absolutely fantastic. It is a real wilderness area. You can see here the field station boardwalk from this drone view that leads to the trail that goes out over two islands, and then the boardwalk ends way out here in the center in the string bog, which we'll talk about later. So other than that one trail in the center of the bog, it's really kind of a trackless wilderness. Uh, the um, the what I'm going to talk about today is kind of, I guess the theme is pretty much a brief summary of everything I know about the Cedarburg Bog. Um, is there a problem that can people hear me? Chris, is
Yeah,
everything
yeah,
okay?
they can hear. A couple of people
Okay.
have unmuted, and so I'm just gonna keep muting them.
Okay.
Thanks.
Okay,
Sorry.
so, sorry for the interruption. Um, so we're gonna talk about the glacial history of the area of the Cedarburg Bog. What formed the landforms of the bog and the bog basin? How did it get here? And then that leads directly into a consideration of the hydrology of the bog, which has to start with some understanding of the bog's water budget and how groundwater gets into the bog and how water flows through the bog, flows through and out of the bog. And then very briefly, talk about the plant communities of the bog and how that relates to the original vegetation of Wisconsin in this part of the state and why the Cedarburg Bog is now unique in southeastern Wisconsin. And very briefly, the animal communities. I'm going to try to stay as close to an hour as I can, but I know that it's going to take a little more than that. The Cedarburg Bog is in a really interesting place in terms of its glacial history because of repeated advances and retreats of the glaciers in this area. 22,000 years ago, where the Cedarburg Bog is, was covered by the proverbial mile thick sheet of ice. But by 4,000 years after that, 18,000 years ago, the ice sheet had retreated back away so that it was no longer covering the Cedarburg Bog area. You can see the periglacial Lake Michigan in its basin there at that time, 18,000 years ago. But after that, there were repeated readvances so that over the next 500 years, the ice readvanced down Lake Michigan, the Lake Michigan basin, and advanced right back to the edge of where the Cedarburg Bog is currently located. So in that interval, there were 500 years. There were probably boreal forests that developed in this area that again got sort of wiped out by the ice as it readvanced. 17,000 years, 500 years later, the ice margin had changed a little bit, but it was essentially right at where the bog is now. So there's real active glacial history. By 16,000 years ago, the ice sheet had receded so that it actually there wasn't any glacial ice in Wisconsin at that point. It had receded all the way out of Wisconsin. But by 750 years later, it readvanced again down the Lake Michigan basin, right to the edge of where the Cedarburg Bog is. So in all these, when the glacial geologists call a glacial phase sort of a geological event, which means that a glacier advanced to a particular place and stopped at that point. And when the glacial edge, the margin of the ice sheet is in an area, that's when you get all sorts of interesting things happening because of wash off the glacier, sediments washing off, chunks of ice breaking off. And you can see right here where the Cedarburg Bog is that it's real active in terms of all of these defined glacial phases, places that the glacier stopped over this glacial history. And if we look at this is a shaded topographic relief map of this part of southeastern Wisconsin. Here's the Cedarburg Bog, here, this relatively flat area. And you can see just east of the bog that there are these north-south kind of landscape features that are roughly parallel to the Lake Michigan shoreline. I've kind of tried to trace some of them in here. Those are all because of times that the glacier was advancing, retreating, stopping a little while it was retreating. And if we look at that in more detail, this shaded relief map, we can see that, for example, Mole Creek, just east of the Cedarburg Bog, the Cedarburg Bog state-owned areas are highlighted in green here, but the bog itself, you can see, is this real flat feature through here on this relief map. And Mole Creek, in fact, at this point has two channels. They meet just a little bit south of here before they flow into the Milwaukee River in Grafton. You can see the Milwaukee River off to the east. And the bog basin is probably here because at some point in all those glacial advances, some huge chunks of ice broke off and got buried in the place where the Cedarburg Bog is. And when they melted away, they left enough of a depression that it was below the groundwater table and filled with water and filled with wetland. So if we look at the glacial deposits in this area, and this is a map from a really nice publication, the Quaternary Geology of Ozaukee and Washington Counties, Wisconsin, by the Wisconsin Geological and Natural History Survey. And if we look, we see that the brown is just says that basically this is the soils here are peat. But the pink is glacial outwash. This is sand and gravel that was deposited by braided streams running off the edge of the glacier, which again, at various periods, it was essentially right here. And this greenish, grayish symbol here is end moraine. So it's a hummocky deposits that were laid down, deposited at the margin of the glacier. So right here is where the glacier stopped, and we can thank all of these interesting landscape features we have to the activity readvances of the glacier. So let's just look real quickly at a cross section of the glacial deposits, both at the north end and the south end of the bog, because it's really nice in this publication they have those. If we look at this, this is the cross section from just north of the bog, running through Gull Lake here. And this little yellow line that I put on here is roughly the extent of that previous figure that I showed you from east to west. Here's Gull Lake. These different colors represent the deposit of different phases of the glaciers, so that you see that there's the Wabaka and the Holy Hill formations were laying down these deposits in this part of the basin, and right at the surface up north of the bog, it's all stream and gravel, sand, gravel, stream deposits. The term diamictin just essentially is synonymous with glacial till. It's just a sediment with a wide range of particle sizes. So even this cross-sectional map shows this real um, interesting, complex glacial history. And then if we look at a cross-section that runs just right across the very southern boundary of the bog, we see the same kind of thing with deposits from the Oak Creek Formation, which is the green part in here, and from the Wabaka Formation, Oak Creek and Wabaka, which is the pink part. And again, the Cedarburg Bog lying right at the edge of where this glacier was stopping all the time. And in fact, if you look at this map of the one of the maximum extents of the Lake Michigan lobe of the glacier and look at the landscape in here, the vertical dimension here is greatly exaggerated, 85 times, but nonetheless, you can see that the Cedarburg Bog is right at what is essentially the edge of the glacial basin of Lake Michigan. We're right there. So what does all that mean about the um, the landscape here, and what do we know about the actual basin itself? What does the bottom of the bog look like? Well, I was interested in that for a long time, and I guess we could call it research if you can call something research that essentially involves going out, getting through the bog, mostly in the winter when it's frozen, cutting a hole in the ice and pushing a rod down, sections of a rod that are threaded together, and pushing them down until they stop, and recording that depth to the surface of the peat. If that's research, we did a lot of research because we have recorded the depths, I and others. Some of this started before I got to the field station at 611 points in the bog, and that's represented by all the black dots on this figure. And you can see, we'll talk later about kind of the distribution of where these samples were, but you can see I've labeled some of the contours. So this is the bathymetric depth of the bog, if bathymetry is the right word, and it's in meters. And I've labeled some of the contour lines on here with the meters. So this is the peat and lake sediments are 2 meters deep, 3 meters deep, 4 meters, 6 meters. You can see over here that as far as we know, this is a relatively shallow part of the bog basin that's sort of gradually sloping from the east toward Mud Lake here, 1 meter, 2 meters, 3 meters. So from this contour map, it looks like this is much of the bog is a relatively flat kind of basin, but there are some real deep holes. This is the boardwalk going out over two islands and ending in the center of the bog out here. And just right between these are the islands. These are four of the 9 islands in the bog. The island down in Mud Lake, the one north of Mud Lake, kind of in the surrounded by cattails and bulrushes, and then the 2 islands that the boardwalk goes over. And you can see that between those islands, there's holes that we've recorded holes that are 50 feet deep from the surface of the peat down to the clay and the sand at the bottom. So those are some real interesting, deep, essentially kettle holes. What the picture we have of the bog is if you've been in the field station upland woods and see that extreme kettle hole kind of northern kettle moraine kind of topography up here with those real deep kettle holes, that topography extends to the east right under the bog, but it's just lower over here. So it's filled with water and filled with peat. But it continues to the east, buried now by just lake and peat sediments. So there are also places with real deep kettle hole topography at the north end. For example, up here in Horn Lake, or it's also called Big and Little Bimeborn Lakes. They have different names. But there's a 43-foot deep hole up there. Watts Lake, when I was doing this in a real systematic way, you can see that we scattered these points all over around here so that we actually could get a pretty decent picture of the depth of the basin. That's not been done for all of the bog. We'll talk a little bit more about that. But I can't tell you right now why I never went out on Watts Lake when it was frozen and cut a hole in there and sounded the depth of the basin at that point. But I know that this isn't accurate, which is showing that the depth is like 4 meters here, because in fact, Watts Lake itself is about 30 feet deep. So I know there's a deep hole under Watts Lake. It still remains to be explored. And that leads to the issue of there's still a lot of citizen, which is definitely not rocket science, that can be done out in the Cedarburg Bog. We could definitely go up. We could go up tomorrow and find out how deep it is under Watts Lake. The 611 soundings are just not evenly distributed. Some of these that were done before my time were done on transects that Tom Grittinger did when he did one of the original studies of the bog. And so there are big areas down here on the south that have not been sounded at all. And in fact, there'd be plenty of room for some more deep holes in this part of the bog. But as far as we know, much of the bog is a relatively shallow basin, but there are these deep holes. And we know that this was a lake. And I'll go into the fact that it probably was not a lake. It was probably a chain of lakes connected by wetlands at some point after the glaciers receded. But we know that at times in its history, it was not a lake, but it was at least probably at least three different lake levels. And the evidence for that is if we look at these red arrows here, they're pointing to a feature on this topographic map, a real distinct feature, which is this very, very distinct ice push ridge or ice berm at the margin of the bog. And the elevation with ice berms, ice ridges are formed at the edges of large, relatively flat, shallow lakes. When the ice expands and contracts over the course of the winter, it exerts just a tremendous force where it grounds out at the margin of the lake and can push up big mounds of earth and boulders. In fact, if you go out the boardwalk right at the edge of the bog, you see a big boulder which was not placed there by anyone except the glaciers, essentially, or the ice on the not the glaciers, but the ice on the lake. And the elevation of these ice push ridges that are at the very high ones around the margin of the bog also corresponds with what would be a lake level that would cause the island that the boardwalk goes over to be so flat topped. The flat top nature of that island suggests that at one point there was a lake level that was maybe just 2 feet, 2 feet, 3 feet over the top of that island, and that the wave action and the ice action in the winter would have just essentially scoured that island flattened it off. It's unnaturally flat, essentially. And that elevation of a lake level that would be just over the top of that island really corresponds well with what would have been a lake level probably when the glaciers were in the area that would have caused this ice push ridge. Then, if we look at the margin of the islands, either this one out here that the boardwalk goes over or the island that's down north of Mud Lake, we see another ice push ridge, which is completely rings the margin of this island, but that's considerably lower in elevation than the one at the margin of the bog. So that was an ice push ridge with some lake level that was lower than this one, but higher than the present level of the bog. And then if we look as we walk over that island that the boardwalk goes over, almost the entire island is ringed by a terrace, which this yellow arrow here is pointing to, with kind of a minor ice push ridge at the base of that terrace. And those were probably formed by a lake that was pretty much at the level that the bog is now. So we have good evidence of at least three different lake levels for the bog over time. I think these ice push ridges are so cool and distinct. I was just going to show you a couple more of these topographic maps with the ice berms, which are around essentially the whole southern three-quarters of the bog. You can see that distinct line just bordering it. And in fact, it's kind of cool that there are places where the lake ice, when at that high lake level, actually grounded out here and formed this ridge, but there's more wetland behind the ridge. So this was the ice push ridge that was formed and wetland outside of that, which is really neat areas to get into. Now, speaking of neat areas to get into, in 1991, when I did the first vegetation survey of the bog, this is up sort of toward the northeast end of the bog. And you can see on this topographic map here, which we didn't have at the time, this feature in here, which is essentially an ice push ridge, I think. But when I was deep in the bog and walking across and had never traversed that area before, and I got to this long thin line, it honestly looked like an ancient road or something. And at first, it was almost kind of, I don't know, it was a little spooky to encounter that in the bog when I had been walking through a mile of wetland already to get to it. And it's clearly an ice push ridge, a place the ice had grounded out. Anyway, so the bog was a lake. The bog was a lake with different levels, but what's it full of now? There are lakes. There's lakes at the north end. There's Long Lake, Donut Lake, Mud Lake, but most of the bog is filled with peat and muck and lake sediments. And uniformly through the bog, the top 8 to 10 feet is peat and muck. Peat is sort of pure organic sediments, materials that deposited with the undecomposed remains of plants. And when that gets decomposed enough so that you really can't identify the fibers anymore, you can't tell what kind of plant made those fibers, then we call it muck. But muck is just really decomposed peat. But below that 8 to 10 feet, where the basin is deeper than that, is a really interesting lake sediment, which is called gyttja, named, I think it's a Swedish term, gyttja. And if you ever get a chance, when we sometimes have events where we pull up a core from the area around where the boardwalk crosses the bog stream and pull up a piece of this stuff, you should get a chance to take it because it's got the strangest gelatinous kind of consistency. It turns out that it's almost pure organic, but it's not black. It when when lake sediments, in this case, this organic matter gets decomposed far enough anaerobically, it actually loses its black color and gets to be more of mostly a gray color. But you can see all these different, this is a 4 foot section of what's essentially a 30-foot core, but this is a 4 foot from here to the top to bottom. And it's about 2.5 inches in diameter is the core. And this is a core that's sliced in half. So the two sides of the core are laying next to each other. And you can see all these lamina and striations in here that represent something different about the environment. This represents hundreds, thousands of years, actually, of deposits at the bottom of this basin of the bog. And over that time, different things growing around the margins, different temperatures, different productivities of the lake, probably different lake levels caused all these different laminations as this organic matter would sink and further decompose at the bottom of the lake. And the stuff that's in it is absolutely fantastic. I mean, there's different kinds of seeds that you find that are identifiable. One of the real common seeds up in this upper right corner is nias seeds, and nias is an aquatic plant that grows in the bog right now. It grows in Mud Lake. There are other places where there are dense packets of shells. There are identifiable plant fibers, like this is part of an equisetum. Um, we found compound eyes of insects, identifiable parts of oak leaves, fish scales, all kinds of evidence in this gelatinous kind of really cool lake sediment below it. And in some places, we don't know what the change in the environment was that would cause something like that. But in some places, there are these just packed, rich zones that are just full of all different kinds of shells. So something was going on so that part or that depth of the lake at that time was extremely productive in terms of this shell-rich zone, all representing changes in the environment over a long time that it was a lake. And then, so the top 8 to 10 feet is muck, peat. Below that is this gyttja lake sediment. And then if you get to the bottom, pretty much uniformly through the basin is this real tight gray clay. Clay it's of course waterlogged. It's got all the pores in this clay are full of water, but clay is essentially almost impervious to water flow. It's essentially a sealed basin that's lining the bottom of the bog. And in places there were very few places where we could actually push the core through that clay because the clay is so tight, and we were just pushing it by hand essentially. But in the places where we could every once in a while get through the clay, we would find this real fine sand below it. So the picture of the bog is that the basin is lined with this impervious layer, which is really important, I think. Well, and I know, which is really important to the hydrology of the bog and the groundwater relations of the bog. So we've talked about the glacial history of the bog briefly, about how or why maybe that would have formed the different landforms we have and what we know about the bog's basin, the shape of the bottom of the bog. And that kind of leads pretty directly into thinking about the hydrology of the bog, its water budget, its water relations overall, the groundwater that gets into the bog, how much groundwater input is there in the bog, and then questions of how does water flow through the bog internally, and what can we learn or assume about that. So first of all, and very briefly, a water budget of any wetland like this is just a balance of inflows and outflows over time. And the Cedarburg Bog is essentially a big, relatively flat. I mean, yes, there are 50-foot deep parts of the bog, but the bog, right in here is a mile and a half across. And so if you draw a cross section of the bog, even if you draw that 50-foot deep part, you better use a real fine pen and draw it real large if you're even going to keep the lines apart. So it's like a big saucer that's clay lined, and it has some storage capacity. It holds water in it. In dry periods, the water level falls. In wet periods, the water level comes up. But in our area, well, let me step back. The inputs to the bog, the possible sources of water in the bog are direct precipitation, groundwater inflow, and then potentially stream inflow, although there really are no streams, nothing you would call a stream that enters the bog. And then the outflows from the bog are evapotranspiration, so loss to the atmosphere from water and plants, potentially groundwater outflow. And then we know that there is one stream that flows off the southwestern part of the bog out of Mud Lake. So some of these components can be measured relatively accurately, and some of them we kind of have to solve the equation for. So we know that, interestingly, I always think it's interesting, precipitation in our area very closely almost balances exactly the potential evapotranspiration in our area. So in one period where we had stream flow measured over a couple year period, we measured the average precipitation over that couple year period and the average evapotranspiration. And the way these are expressed, you see they're just expressed in inches. That would be in depth of water over any part of the bog. So over any, whether you want to take the whole bog or whether you want to take an acre of the bog, or, well, in this case, we want to take the whole bog and say that there were 35 inches of rain fell on that bog, and there were 33.4 inches of evapotranspiration from that over essentially a 1 year period. This is, and over that average 1 year period, we could measure the stream flow. Those are things you can measure relatively well, and the stream flow out from the bog was accounted for about 2.4 inches of lower water levels from the bog. So you can see that the major components are direct precipitation and evapotranspiration out. I think that the groundwater outflow from the bog is essentially, it's negligible. I think it's essentially zero because of that clay lining. And the stream inflow is really not great into the bog either. And so if we solve that equation, we find out that with 35 inches coming in and 33.4 inches going out to the air and 2.4 inches going out for the stream, we end up with a negative balance. So we need a little more water to keep the bog filled at a sort of average level that it has, and that probably represents the groundwater inflow to the bog. So the groundwater inflow is about 2%, we think. This is a rough estimation, but it's probably pretty close. And what we do know, I think, is that compared to the amount of direct precipitation on the bog, the amount of groundwater getting in is really small. 2% of the water input budget. But it's a small amount of water, but it's really important for the chemical budget of the bog. And we'll talk more about that later. But our water is so highly calcareous in the area that 2% of the budget coming in as groundwater is enough to keep the pH of the bog neutral all year long. We're going to talk about the fact it's not a bog. It doesn't develop acidic conditions. It's neutral. It's a minerotrophic fen, technically, we'll talk more about. Also, the surface water drainage basin of the bog for a wetland this size is really small. The entire surface water drainage basin of the bog is only about twice the size of the actual acreage of the bog. So most of the water that gets into the bog is direct precipitation or real shallow groundwater flow from the immediate area. So what's the picture? What's the picture we have of the groundwater relations of the bog? If we do a cross section, this is from a very nice publication by David Hart and Joanne Klein about the groundwater relations of the Cedarburg Bog. And this top cross section represents this cross section shown right here through the Cedarburg Bog from the north branch of Cedar Creek to Mole Creek off to the east. So here's Mole Creek, here's north branch of Cedar Creek. Of course, the vertical dimension is greatly exaggerated here. And what you see is the ground surface. The gray is the unsaturated glacial till. The bedrock is down below. And through our area, the blue represents groundwater saturated glacial till. And what you see from this is that the Cedarburg Bog is essentially sitting at what is a regional groundwater high, and that all of the groundwater in our area is kind of flowing from the west, the north and the west, off to the east toward Mole Creek and toward Milwaukee River to the east. This is another view of that. It shows that these blue lines are the topographic map or the contour map of the groundwater in our area, and they're hard for you to read, but what they're showing is that the groundwater table is falling from the Cedarburg Bog off to the east. Most of the bog, there's the potential for water to flow out of the bog. In other words, for it to be a groundwater recharge area, but I don't think that happens because of that clay lining. And besides, if the Cedarburg Bog was a major groundwater recharge area, it would be dry because the water would flow out into the ground. If we look at the topographic setting of the bog, this is a topographic map from the Ozaukee County GIS layers. And you see the bog, this flat area in here. Which you can't, but I have, if you could read these contour maps, you'd find out that the Cedarburg Bog elevation is only about 10 feet higher than the north branch of Cedar Creek off to the west. So there's not a lot of topographic gradient to get water to flow out of the bog to the west. But on the other hand, to the east, the Cedarburg Bog is 82 feet higher than Mole Creek, which is just half mile off here to the east, and 120 feet higher than the Milwaukee River, just to the east of the bog. So topographically, this is falling. We already saw that with this Lake Michigan basin over here, and the groundwater is flowing off to the east through here. Um, it's the Mud Lake is about 37 feet higher than where its outlet stream meets Cedar Creek, and the bog is definitely perched by this clay lining because the bog level itself, the water in the bog, is 21 feet higher than this spring-fed lake on the golf course just to the east of the bog. So here's a summary. Here's my picture of the groundwater relations of the bog. Again, with the vertical dimension exaggerated, but this is to the west and to the north. This is to the south and the east. The groundwater table is sloping from the north and west to the south and east. The clay lining is holding water in the bog so that on the west and the north side of the bog, there's the potential for groundwater to flow in, for it to enter the bog on this side. But by the time you get to the east side of the bog is perched way above the groundwater table. And the water's being held in by that clay lining. And we know that groundwater comes into the bog because we know of some areas where there are discrete springs. I think groundwater probably seeps in a lot of this north and west side of the bog, but these places that I've shown here in yellow are discrete springs. You can walk up to them, you can see the water bubbling out of the ground. And I've mapped this blue area as the area where I think most of the groundwater enters the bog. And the reason I've extended it out kind of a little bit away from just the margin and these discrete springs is because this is the part of the bog where you find skunk cabbage. And skunk cabbage is a known good indicator of groundwater seepage. And you really there's essentially no skunk cabbage, very little skunk cabbage in any other part of the bog except this area in here. Um, but and the bog is not flat, and we're going to talk more about that picture of the bog as one big lake in a minute. But we know that the bog isn't flat. If we would read these contour lines from the Ozaukee County GIS, we find out that the north end of the bog is about 8 feet higher than Mud Lake and the outlet stream at the south end. So there is the potential for a constant, albeit slow, flow of surface water from the north to the south and out the outlet stream. This is the only outlet stream. And I say it's slow, and I think it really is. I think I would love to know how long it takes a drop of water to get from the north end of the bog down to Mud Lake. I think it could be measured in years, as far as I know. Um, so just to go back to this for just a second, at one point I know that I pictured the bog being this big lake after the glaciers receded. Um, when the outlet level dropped to the current elevation, the bog really would have been a chain of lakes embedded in a large wetland because we have this peak depth up here, which is 2 meters, but we know that the north end of the bog is 8 feet higher than the south end of the bog. So it's not a flat system to start with. And so the complicated picture is something like this. If this blue line is a flat lake level and the green line is the surface level of the bog and the black is some made up imagined basin of the bog. And what we did to contour that basin was measured from the peat surface. So these are our cores going down and measuring the depth. We it looks like it could all be a lake when you do that, but when you find out that it's not flat, you'd find out that in fact, when the outlet level dropped to the current elevation, the bog would have been kind of a chain of lakes embedded in a large wetland complex, not one big lake. But at any rate, The bog slopes, there's flow of water from the north to the south. And what we know about flow of water in wetlands is that it's almost all at the surface. When plants grow, plants have fibers. When plants die, they fall down horizontally. So the plant fibers in less decomposed peat at the surface are oriented pretty much horizontally, and the permeability through peat and muck is almost entirely, it's way higher horizontally than it is vertically. Below the surface, the peat becomes decomposed and compressed, and muck has very low hydraulic conductivity. So the flow of water, if this is in this sort of stylized diagram, this is depth in centimeters from the surface. So this would be like just 4 inches, 10 centimeters. And the hydraulic conductivity, and you can see that the hydraulic conductivity is falling rapidly as you get to something like, 8 inches of depth. And this is just sort of true of all wetland soils. This isn't something special about the Cedarburg Bog, but the hydraulic conductivity at the surface of the peat is 100 times what it is at just 8 to 10 inches below. The picture we have is that the flow through the bog at the surface is at the surface, over the surface, and in the very shallow peat at the surface. And below that, the water in the bog is essentially stagnant. I mean, it's ancient water that we would pull up from one of those cores down deep in the bog. So how does this surface flow? We know something now about the uh, bud water budget of the bog. We've discussed a little bit about how groundwater gets into the bog. How does the surface water flow from the north end of the bog to the south? And one of our best evidences is the fact that there's string bog in the bog. String bog is, and we'll talk a little bit more about it later, but it's a patterned vegetation, and you can see the stringy texture of this vegetation through here. See how all this is oriented in lines, and those lines are formed by stunted cedar and tamarack trees on slightly higher elevations, interspersed with low, flat areas. We know very little about physically what forms string bogs, but one thing that we know globally about string bogs is that the strings are perpendicular to the direction of water flow. So if you see a string through here, you know that the water is flowing not along that string, but across that string. So you see the stringy texture in here, you know this water is flowing into Long Lake. You see all of this down here, you know that the water is flowing out of the south end of Long Lake and down. Mud Lake is way further down to the south and west in here. And so looking over the course of the bog, you can get all this evidence for how it flows. This is the southeastern lobe of the bog, and you can see that all these strings are oriented, and the elevation is such that it would indicate that all of the flow from that part of the bog is to the south and to the west, southwest, toward Mud Lake. So if we put all of that together, um, we see that the groundwater is entering the bog on the north and the west side, and the surface flow that we can track based on flow tracks and based on what we know about string bogs in the bog would give us a pattern that everything's moving kind of gradually to the south and to the southwest, following the easiest course as water always does through that area. This is just a glamour shot of the bog outlet stream. Mud Lake is off, just right up off in here, and this is flowing to your left. The other thing that we know or that we can say about water flow in the bog is that we have these known discrete springs, but we also have water tracks, which are evidenced by poor ice in the winter, weak ice, no ice, the last ice to freeze. And I've been through every part of the bog And the easiest time to travel in the bog is in the winter. So I've been through more of the bog in the winter and more intensely in the winter than at any other time. And I can map the places that there's always bad ice. So there's always a flow track that comes out of Horn or Bimborn Lake and flows down through this part of the bog. This spring at the north end of the bog is just a beautiful, real discrete spring that then flows down into Watts Lake up in here. And there's always bad ice in the winter at the south margin of Donut Lake and at the south margin of Long Lake, because we know that the water is flowing out of those lakes at that point. Here's a flow track. This is Donut Lake and a flow track coming out of um, Donut Lake. And if it's not this obvious, you better know where these parts are when you're walking in the bog in the winter, because otherwise you can easily break through. Here's that flow track actually forms a little, almost like a stream for a little ways before it just disperses. And then at the south end of the bog, there's this real interesting, I think, phenomenon where the water seems to pile up at the north margin of these islands. And so that's always some real treacherous ice. So the ice is telling us a lot about how water flows through the bog. So I guess that's pretty much a summary of what we know about the flow tracks through the bog. I think it'd be fascinating to know more about it. But we have to deal with the fact that the Cedarburg Bog is one horrible name for this wetland. I mean, for one thing, it's not in the town of Cedarburg. It's in the town of Saukville. Cedarburg Bog apparently was a name that somebody in the DNR put on a map a long time ago, not really knowing a lot about the area. It's also not a bog. Um, a bog tends to be an area that's characterized by acidic waters. And that's because in some places, like in northern Wisconsin, they're growing in granitic bedrock. Well, we have very highly calcareous bedrock here, limestone. Or you can get a bog developed because the sole source of water is rainwater, which tends to be slightly acidic. So it develops acidic conditions. But that little bit of groundwater, that 2% of the water budget that comes into the bog is enough to keep its pH neutral all year round. And so what the bog, what the bog is, what the Cedarburg Bog really is the Saukville Swamp. A swamp is a forested wetland. Any forested wetland is called a swamp. And when when the Friends of Cedarburg Bog first began, I tried to convince the board that we should call ourselves the Friends of Saukville Swamp. Well, of course, you can tell that didn't sell at all. And I will continue to call it the Cedarburg Bog, but it's really a horrible name. We could call it the Saukville Swamp or the Saukville Fen. A fen being a wetland where the hydrology, the chemistry is influenced somewhat by groundwater inflow. So we've talked about the glacial history of the bog, the landforms, shape of the bog's basin, what I know, what we know about the hydrology of the bog. We could do whole long talks about the plant communities of the bog and what we know about those, but we're going to really summarize it very briefly here. We sampled with a team, we sampled the vegetation of the Cedarburg Bog at 165 locations in 1991, and we repeated it again in 2006. This was done before we had GPS, and so these transects across the bog, 165 samples, were laid out at every place, every transect a quarter of a mile from north to south. And there was 100 meters between the sample units, all laid out with a compass and a string distance measure. It's a lot of work. And at each sample location, we recorded Every tree, we measured the diameter and species of every tree over 1 inch in diameter within a 100-meter square circle. At the center of that circle, we laid a 10-meter long shrub intersect line and recorded the cover of all the shrub species on that line. And then at the two ends of those lines, we recorded all tree seedlings, so things smaller than an inch in diameter, in two 4-meter square quadrats. And at 1-meter square quadrats, we recorded the cover of all herbaceous species. And we marked those locations permanently with PVC pipe and used the same locations to sample in 1991 and in 2006. So we could look for changes in the vegetation over that 15-year interval. We used data forms, of course. So this was our herbaceous species data form with all of the common stuff that we would find. And we measured and recorded, estimated the cover of every herbaceous species we would find in a 1-meter square quadrat. So these are some sample areas that were done in the swamp forest, and a nice big clump of sphagnum moss in some of the conifer forest had nice clumps of sphagnum. It really is a northern conifer forest swamp. There was also hardwoods in there. Here's yellow birch. The paper birch was also important, as were at one time the ash trees. And so with this big multivariate analysis, where this is our 165 different samples spread out along the line down here. And the orientation of these in this multivariate statistical technique we use puts samples that are as close to the samples are oriented here depending on how similar they are to one another based on the entirety of their vegetation samples. So any two samples down here that are adjacent to one another are closer to one another floristically than a sample that's farther away than that. And you take something like this multivariate statistical technique, and you decide, okay, how many plant communities do I want to identify and what looks distinct? And so in this example, if we want 10 different plant communities, we draw a line across here and we separate those communities based on where that intersects this big dendrogram that we have. And we would have this would be one plant community, this would be a second, this would be a third. If we do that, what we find out is that it's pretty easy to get something in the range of either 12 to 14 distinctly different plant communities in the Cedarburg Bog. But the issue is, which is great. I mean, it's nice to be able to identify and talk about the species composition of 12 or 14 different plant communities. But if you try to map them, you find out that there's a mosaic of different forest types that are all distributed within one kind of area. So, for example, this green area is all what we end up calling conifer swamp. But in fact, within that conifer swamp, there's three different, pretty different, distinct different types of conifer swamp within that, in terms of species composition. But they're all interspersed. They're a mosaic, so you can't map it as anything that's just one contiguous unit. So when we map it, we end up with 8 different wetland communities. There's 9 here, but one of them is islands. There's 9 islands in the bog. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 places where there's a gravel island sticking up out of this post-glacial kind of lake system. And the major plant communities in the bog are conifer swamp, which is about 1,000 acres of the in this map, just 1900. Um, and hardwood swamp down at the south end of the bog is a pretty substantial area. String bog, which I talked about a little bit, this patterned fen is over about 225 acres of the bog. Shrub communities are real complex. There's at least 3 or 4 different shrub communities, but they're all interspersed within an area, and there's about almost 225 acres of shrub communities in the bog. So we have this nice picture of the bog. It's definitely a conifer swamp. Um, in 1991, we recorded 3,700 trees. In 2006, about the same, 3,700 trees. And about 70% of the trees we recorded were conifers, white cedar and tamarack being the most abundant, a very small area of black spruce. The ashes they're all dead now from emerald ash borer, but the ashes were an important component of the forest. And then we see elm, paper birch, yellow birch, red maple, were all important. It's a pretty diverse wetland swamp and a typical composition of a conifer hardwood swamp. Our white cedar and our tamarack. But what's interesting to me in the bog is that you think a white cedar and a tamarack. Well, it's one thing. A tamarack is a tamarack. No, tamaracks at the margin of the bog grow tall and straight and really fast. Tamaracks in the center, in the string bog, there's a dog thrown in for scale there. This is definitely over 100-year-old tree in the center part of the bog. That tiny little scrawny tree, they grow, tamarack especially grows to the capacity of the richness of the place it's growing. And here's cores that are taken from tamarack trees, and you can count the rings in these cores. And I've made them so that they're all about the same size here, about the same uh, magnification. And a hundred millimeters is about 4 inches. So this is a 4 inch line through here, and this 21-year-old tree is about 5 inches in diameter. And this 187-year-old tree is less than 4 inches in diameter. If you uh, lean into your screen real close, you can get the sense that there are lines in here of annual growth rings, but you'd need a, um, a microscope to be able to, we did need a microscope to be able to count those. So they're growing fast at the margin of the bog, especially any place where they can root in the mineral soils at the margin of the bog, and growing very slowly out in the center. There's also a very high diversity of shrubs in the bog. Unfortunately, the most common shrub in the bog is an invasive species, glossy buckthorn, which the Friends are working very hard to control, at least in parts of the bog. We've killed glossy buckthorn, removed it from over 600 acres of the bog. But to have 29 different species of shrubs in 2 or more sample units is pretty high shrub diversity. And you can see that the third most common shrub in the bog is poison sumac. If you're allergic to poison ivy, poison sumac has the same toxin, and the Cedarburg Bog is no place for you if that's the case. So this is in 165 sample units, 109 of them had winterberry, and 76 of them we found poison sumac. Winterberry is a beautiful shrub with the red berries in the winter. Very hard to walk through because the stems kind of intertwine. And then there were a high diversity of herbaceous species. 88 herbaceous species were found in 5 or more sample units. Real high diversity of sedges. 16 of them in purple here were all sedges. And fortunately, only 4 non-native herbaceous species were found commonly in the bog in 5. If we organize this by how many units they were found in as opposed to alphabetically, we can see that there were some species that were really common. Northern bugleweed, Lycopus uniflorus, Ruis pubescens, the dwarf raspberry, tufted loosestrife, northern marsh fern were all found in more than 100 of the 80 or the 165 sample units. Canada mayflower was found in more than half of them. And a lot of these Canada mayflower, purple stemmed aster, starflower, these are all northern conifer swamp kinds of species. Here's some of the real common one, northern bugleweed, dwarf raspberry, tufted loosestrife, foul mannagrass, Canada mayflower, and marsh fern. So in all of these plant communities and this sampling we've got, the one thing that we know is that it really is a northern kind of flavored plant community. It's a conifer swamp, which is much more common in the northern part of the state. And there's about 350 species of plants, vascular plants, that grow in the Cedarburg Bog, and fully 10% of them, like at least 35 plants, are at or near the southern margin of their range. Two of them are trees. Black spruce and white cedar are both pretty close to the southern margin of their range. Black spruce is an outlier in the Cedarburg Bog. There's 4 different species in the blueberry family that are at the southern edge of their range, and a lot of sedges and things in the monocots, and several orchids. There's, I think, 14 species of orchids that grow in the Cedarburg Bog, and 7 or 8 of them are at the southern edge of their range in the Cedarburg Bog. So truly a northern plant community. If we look at the distribution of the trees, we can see that where we are at the Cedarburg Bog is real close to the southern margin of white cedar and is actually an outlier of black spruce. Some of the plants in the bog are incredibly rare. The linear-leaved sundew, I should have something in here for scale. It's a tiny little, absolutely beautiful sundew species. And if you ever get a chance to see this off the edge of the boardwalk in the string bog in the summer, you're looking at probably the rarest plant you'll ever see. There's only a handful of populations of linear-leaved sundew in all of North America, and there's a big population of it in the Cedarburg Bog. And we have one federally threatened species, the eastern prairie fringed orchid. It doesn't bloom, but a lot of the individuals don't bloom typically from year to year, but there's a big population of it out in the string bog, in the Cedarburg Bog. And then a really odd little spot. Remember we talked about that groundwater tracking from the north part, coming in the north and the west, and tracking down through the south, or to the south in here. And if you do that thought experiment of tracking this groundwater down through here and imagining that otherwise it was only rainwater in the bog, you can see that the part of the bog that would pretty much never see any groundwater input would be this southeast lobe down in there. And in fact, that southeast lobe is where we found black spruce. Before we did the survey in 1991, people said there was no black spruce in the Cedarburg Bog. Apparently this part had never been botanized. And this tiny little open wetland spot right down in here, that is the only typical open leatherleaf sphagnum kind of bog-looking area in the entire Cedarburg Bog. So this area right in here, especially this, is the Cedarburg Bog or the Saukville Bog. The rest of it's the Saukville Swamp. There's our tiny little open bog, and the black spruce forest. So this is the real Cedarburg Bog is in there. And then the string bog is the southernmost string bog in North America, probably the world. We know that the strings are oriented at right angles to water flow. They always occur on sloping wetlands. People really don't know how they're formed or mechanically what forms them. And there's often these kind of teardrop shaped islands. We call them islands. They're not gravel islands like this one right over here. They're just a little bit firmer peat floating on the peat surface. A drone photo shows the string bog pretty dramatically. From the ground, it's a lot harder. They're easy to see from the air. It's a lot harder to see the continuity of those from from the ground. And this dome in the background here is one of those floating teardrop kind of dome-shaped islands that are typical of string bogs. Okay, that's pretty much all I have time to say about the vegetation of the Cedarburg Bog, but what makes the Cedarburg Bog unique now? Um, at one time, this is a map of the pre-settlement vegetation in Wisconsin based on the original surveyor's land records, and you can see this break in the colors of the vegetation, especially down in this part, and everything to the north of and east of this blue line in here is all it has a lot of different tree species in it and everything, but it's all dominated by sugar maple. It's all dominated by sugar maple forest in the upland. And where we are here at the Cedarburg Bog, was wall to wall forest pre-settlement. There was no prairie, there was no savanna. It was forest. It was deep, dark maple beech forest in the uplands, and it was forest in the wetlands. And the reason for that is that this is where the fires stopped. Sugar maple is really sensitive to fires, and where it didn't burn, you had deep, dark sugar maple forest with conifer swamps in the wetlands. And where it burned, you had the yellow is prairie, this kind of greenish is oak savanna, and the orange is oak forest. Those are all communities that burned. And where the fires burned through the uplands, they burned right through the wetlands too. So in the wetlands, you have this light blue is sedge meadows, wet prairies, and marshes. So the picture is that pre-settlement, our blue conifer swamp, this is the Cedarburg Bog right here on this map, was the common wetland type in southeast Wisconsin. That's what we had. But it's the only one left, the only one of size left. Everything else has been destroyed. It's been drained, it's been logged, it's been farmed. And so it makes the Cedarburg Bog even more valuable because it's really the last remaining large example of the common pre-settlement vegetation type in our area. So that's why the Cedarburg Bog is unique. This is what I just said, I guess. Okay, so I know I got to wrap up here. Finally, let's talk very briefly about the animal communities of the Cedarburg Bog. The mammals of the field station area are pretty much everything you'd expect to find in this area. Uh, Interestingly, we just added bobcat to it. For a long time, people have said there's bobcat in the area, but the field station is real strict about not adding any kind of species, but especially vertebrate species to its list, unless there's absolutely verified sightings, and we now have game camera pictures of bobcat in the area. But some of the interesting species that are dependent on the Cedarburg Bog are beaver, and we have a good population of river otter. And our most special mammal in this area, in the Cedarburg Bog, is the redback vole. Um, a redback vole is about the size of a white-footed mice. It is this absolutely gorgeous little mouse with this. It's like you want to make a mink coat out of these. You don't really, but it's a beautiful little mouse, and it is the common mouse in the uplands. It's essentially the white-footed mouse of northern Wisconsin in all the uplands. But this far south, the only place that you find redback voles is in a conifer swamp like the Cedarburg Bog. And the Cedarburg Bog has a really nice big population of redback voles. So it's so cool that we actually have a special mammal. River otter, if you go out in the winter to the stream, you can often see these wonderful slides and tracks of river otter. In terms of amphibians and reptiles, we have pretty much everything you'd expect for our area. We have everything that grows in this area at the field station or the Cedarburg Bog, except, of course, for example, those turtle species that require big river systems to grow in. The species that are actually wetland dependent in the area, so that we only find in the bog, are bullfrog, green frog, northern leopard frog, northern water snake, snapping turtle, painted turtle, Blanding's turtle, and just recently, a graduate student at UWM found four-toed salamanders, which is really a northern species, dependent, they say, on sphagnum moss. And it was pretty much found nowhere near any sphagnum moss. But this is bullfrog, leopard frog, green frog, and a species or a picture of a four-toed salamander. You can see it's at the Cedarburg Bog here. It's pretty well outside of its main range, but it's kind of an interesting species in that it apparently is, for some reason, has a lot of little bitty outlier populations. Here's some of our real wetland dependent species, not really in the upland that much, but snapping turtle, we have a pretty good population, I think, of Blanding's turtle, painted turtle, and this heavy-bodied water snake that grows in Mud Lake. Bird species, I'm going to be real quick here. I'm almost done. And I'm really outside of my area here. I'm not only not an ornithologist, I'm not even really a birder. But there's 135 species that are possible breeders in the bog. About 60 of those are common. The 60 common breeding bird species of the Cedarburg Bog important bird area that breed here is a pretty good high diversity of birds. And just like the plants, there's several of those. I think 18 species that John Itzikowski found when he researched that are really at the southern margin of their range in the breeding in the Cedarburg Bog. Most of those are either considered uncommon or rare breeders in our area, but three of them, the swamp sparrow, veery, and white-throated sparrow, are common in the Cedarburg Bog and really don't breed any farther south than this at all. The Cedarburg Bog is kind of, especially for the white-throated sparrow, my understanding is it's kind of an outlier population. And you can see those birds here in their range, with the orange being the breeding range of those birds. And I guess it just impresses me that there are so many parts of the biology, the flora and the fauna of the bog, that are kind of at the margin of their range. So the breeding bird with the margin of their range right at the Cedarburg Bog are pretty common. I'm interested in the fact that in terms of birds that we have that live here all the time, that are native birds, stay on our territory here all year round, well, there's only 14 native birds that are really here all the time. Things like chickadees, or 18, I should say. I'm sorry. 14 of them are pretty common. And some of them are non-native. We have more birds than that, 22 birds that can be found here either in the winter or the summer, but our birds in those individuals, the birds we have here in the winter come from the north, further north, and the birds we have here in the summer come from further south. So they're not permanent residents. So anyway, I know that was rushed through the annals, but that's pretty much my summary of the Cedarburg Bog. And I know we're close to the end of the time we said we had, but I would be glad to stay and answer questions if anybody has any or discussion.
That's great. I think first of all, we want to thank you, Jim. That was, I don't know what tour de force even really means, but that it must be what you just did. That was really spectacular. It's such a wealth of information, your experience, and stories well told. So thank you so much. There are a couple of comments, questions in the comments, and I can read those to you. And if people want to stick around a bit longer to hear your answers, that would be great. And then if we turn off the recording and people are still wanting to ask more questions, we can hang on a little bit beyond that. But actually, why don't we, Jeff, I saw you had your hand up right away. Why don't we go to you first, and then we can read questions if you want to unmute.
Sorry, I didn't have a question.
Didn't,
But
just
I'll just
raising
say,
your
Jim, this
hand.
was amazing. Yeah, that was by mistake. But Jim, this
Thanks,
was
Jeff.
absolutely extraordinary. Thank you so much.
Thank
Yeah.
you.
Jim, there's one question. Any badgers as you were getting into the wildlife?
Yes, there are badgers in this area. I live and own property just sort of off the corner of the Cedarburg Bog, and I have badgers real active on my property. And in the badgers, of course, I don't know that they'd ever really go into the bog. They're kind of a 13 line ground squirrel special hunting specialist, as I understand them. But the
Yeah,
field station has badger activity, has had badger activity in its uplands, sandy uplands in the past.
sure. And then another question asking about the Beulah Bog near Eagle, if you're familiar with that and want to talk about any similarities.
Um, that's a true bog. I mean, it's considered more, I think, of a true acidic bog than the Cedarburg Bog. It's tiny. I mean, so the comparison is you're talking about a tiny little place, and the Beulah Bog is likely much like something we didn't talk about at all, which is another natural area at the field station, owned by the field station, which is the Sapa Spruce Bog, which is a tiny little bog just north of the main field station. That is a true acidic bog, and it's acidic because the wetland itself is domed, and the whole dome of the wetland um, floats up and down based on water levels as the water levels change. And so the center dome of the wetland really never gets any groundwater. It only gets rainwater. And I suspect the Beulah bog may be a lot like that.
Okay, interesting. And Erica Young, no relation. Um,
Yeah.
do you want to ask your question, Erica?
Um, I actually didn't have a question. I was just yeah, thinking of Sapa. I was thinking of the southeast little tamarack spruce thing there, and I was thinking it's like a little Sapa bog that's just been plonked in the middle there because it's being deprived of that, or it has isn't getting that groundwater flow. So that was kind of it would be interesting to look at a floristic comparison between that section and Sapa, but I don't know if there is any floristic material on Sapa bog. Is there, Jim?
There's some, yeah, we have a species list of the bog, and there's a species of Eriophorum cotton grass that I think only grows in the Sapa bog and that part of the bog, um, or that part of the Cedarburg wetland. Um, and yeah, it's just fascinating to think about the fact that lobe of the Cedarburg bog over there, I'm sure has never seen anything but rainwater for thousands of years. And the center of the Sapa bog is the same thing. But yeah, thanks for that comment, Eric.
Yeah, there's another
Yeah,
question.
thank you.
Yeah, a question about the beach blight aphids. Any evidence of those?
Ooh,
This is coming from Melanie.
Yeah, I wish that that I knew the story better. We have the aphid. We have the aphid at the field station, but we don't yet have the fungus associated with that aphid. So as far as I know, somebody can correct me if I'm wrong, but as far as I know, we don't yet have beech blight at the field station because we don't have both components, both the aphid and the fungus that the aphid it introduces because of its feeding damage. So
Okay.
as far as I know, someone jump in and correct me if I'm wrong, but I don't think we have the blight yet. It is likely coming.
Yeah,
That's
I don't
an,
know
that's
if
an
Melanie
interesting
wants.
story that if I'm getting this right, beech blight is caused by a native fungus, but the native fungus normally doesn't attack beech very effectively until we get a non-native aphid that the feeding holds, the damage that the aphid makes in the tree is enough to introduce this native fungus so that the fungus becomes pathogenic on the beech, which it normally wouldn't do except for this non-native insect that's causing its introduction. So it's a real complex biology, ecology.
Yeah. And if you can see into the future, Jim, what's going to take the place of the dead ash trees, the different species we're losing?
Well, I think there is hope actually that we're going to get ash back because there is some hope that there will be some genetic resistance to damage by this borer. This borer came from Asia, and there's plenty of ash in Asia, and the emerald ash borer is actually rare over there because the ash over there know how to defend themselves, presumably chemically, against this incredible amount of damage that it causes on our novel ash over here.
Mhm.
And there are people who think that in the seedling cohort that's still out there, seedlings and saplings, that
Mhm.
there may be some resistant trees coming up. Otherwise, I think one thing that would be great is for the Friends of Cedarburg Bog, the field station, the DNR to start a program of actually planting tamarack trees in some of the areas where the ash canopy has been lost because bare root tamarack seedlings are very easy to plant in the muck. And a graduate student and I, a long time ago, Ann Rice, and I did work where we planted tamarack in parts of the bog right along the boardwalk is one of our sample or study plots. And it grows like crazy. It does really well and forms a beautiful tamarack. So there is tamarack reproduction throughout the bog. We found that with our vegetation sampling, but we could really boost that up by introducing more tamarack in some of those areas.
Okay. And there's one other comment that kind of skipped over. It's not a question, but a description of the four-toed salamanders you mentioned. Angela has seen those. I don't know if you want to unmute and chime in, Angela, about that.
Just sharing that we've found them several years since and more abundance, which is always awesome.
In the Cedarburg Bog?
No, in the same spot that they were originally discovered, on the field station property in a lower area, um, in some really moist dead tree cover.
That's so cool because if you read about the biology of it, at least what I read, it talks about this real dependence on sphagnum moss. And where you guys found that four-toed salamander essentially in the upland woods near Ephemeral
Yeah.
ponds, there's there's no sphagnum moss within, I don't know, a mile and a half of there. It's That's interesting and pretty cool.
Yeah.
That's great. And Michelle had a question about the ephemeral ponds. I think you talked about it a little bit early on, but Michelle joined us in progress. Michelle, do you want to say a little more about your question?
I was just wondering if the discrete springs are what feed the ephemeral ponds, basically.
No, no, no. The what we always talk about, the ephemeral ponds are they are sitting in the groundwater table, but they're real low spots in kettle holes up in the upland woods. And they're low spots that tend to be full of water in the spring when the groundwater, shallow groundwater levels are high. And then as those groundwater levels fall, they kind of, some of them, most of them dry out, hence called ephemeral. But they you know, in a sense, they're associated with the groundwater in that they're sitting in the shallow groundwater table. But I wouldn't call them a spring in any sense because they have no outlet. So there's not a groundwater discharge happening from those. I hope that makes sense.
It does. Yeah, thank you. I came in a little late, so I appreciate the explanation. Thanks.
Great. And I'll just reiterate, we have been recording this and we will be making it available. I'm going to hand it off to the Friends group to post with their, I think with their YouTube channel. So Jim's got the Bog Friends um, web address right here on the screen, and you'll want to come back to that for lots of reasons. I'm going to stop that recording now, and if anybody wants to stick around and just offer a few words of thanks to Jim. But again, it's been a real pleasure.